Not this video only need recorder has started. OK， 好，终于，然后我要，好，应该可以了。Okay, good. So let's start. Just quick recap that we're going to use P equal to K delta to describe the deformation of a bar under or subjected to the force. Okay, maybe I forgot to draw this force P here, but I guess you know that. Okay, and oh, here. So P equal to K delta and the K equal to EA divided by L, which means that the K considering taking the material properties and geometry into account. Okay. And this example tell us that we can get the force, internal force, by cutting the place you want to see, right? So we cut it and we separate it into two parts. The first part is upper part, the other is down bottom. Okay, and then you do the force equilibrium for upper part, and then you notice that after the moment balance, you can get your assumption is wrong, was wrong, and then you can change the direction. And then really important thing is that when you get the force on the upper part, and you also notice that for bottom part, you will have the force opposite, but with the same value for its counterpart, right? So you see here's downward, and this one will be upward, and this is upward, this is downward. So which means that when you take a bottom part, you can see that this material under the elongation, the other part is compression. Okay, so careful, don't think this one is up, this sorry, downward is upper, and you thought that this force is downward. Oh, no. You need to see them separately. And these two force, these pair of force should be cancel each other. So the direction will be different. Okay, so be careful about this. And then we use the rigid behavior of the bar ABC to get the deformation relationship, okay, displacement relationship, and then you can get the similar triangles, and then you can get that E should be equal to something. Okay, that's it. And this one is really important, so please pay attention on this. This is a little bit complicated, so let's take a look. There's a bar. Okay, here is only one bar. Okay, these three are free body diagram. You just cut it, and then get this one. Okay, so they are all the same bar, only one bar here. Okay, but this bar subjected to three forces, up, down, down. Okay, and then firstly we can take a look. For example, if you want to see the goal of this page is going to determine the total deformation, total displacement of this bar, which is the displacement of D. Okay, displacement of D. So what will it be? It will be each section, each deformation of a section, summing up together, it will be the displacement or total deformation of this bar. So let's get each bar has its own deformation. Okay, and if you want to get the deformation of each section, we need to get the internal force for each segment. Yeah. So for example, if we want to get the AB section force, we just cut it. We cut it, and we can get we can force balance for the bottom part or upper part. Okay. So I will do bottom part first. Okay, bottom part. Dun. If we cut it, and then we found that, yes, the B here has the force upward, C is downward. No problem, no problem, right? And PD downward, of course. So what is N1? N1 is the internal force in the section, in the AB section. So what is N1? N1 should be, so N1 plus PB minus PC minus PD will equal to 0, right? So if we put N1 to the left-hand side, so B1 to the right, PB will be right-hand side will be negative, and PC, PD will be plus. See? Up, plus, minus, right? So N1 is in the left-hand side, this one will be minus, and then plus, right? So just moving around. So N1 equal to this one. N1 equal, so to maintain this part force balance, right? So now this is the bottom part. How about if I do upper part? What will it be? We believe we will have exactly the same result, but I will show you. Okay, so now upper part will be looks like this, right? Right? And what is the N1? Still N1 here. I assume so it should be upward, right? I assume positive. I here, see, a positive. So everything every force I want to determine, I just assume it upward. It's okay. And then what is the upper part force? You see, this upper part force should be the RA, right? RA is provided by the fixed ceiling, right? So RA should be the reaction force for this bar. So it should be RA, what is RA? RA equal to, what is that? Minus PB plus PC plus PD, right? Because in this whole diagram, RA positive, PB positive, PC negative, PD negative equal to 0. So RA stay on the left-hand side. If you move all the rest, turn to the right, it should be RA equal to minus PB plus PC plus PD. So N1 equal to minus RA. Okay? So you see the value minus PB plus PC. Don't you think they are the same? The value is the same. The direction, maybe you say, N1 is minus I. Yeah, because the answer of this and answer of that will cancel each other out, right? So you see upper part balance, bottom part balance, they are all the same. They are all the same. So from now on, I just choose one of them. Okay. So if you're doubt of it, you feel nervous about it, you can do both when you back home. Okay. So you will know that exact when you do the force balance correctly, every time you will get the same result. Okay. So N1 equal to this one. How about N2? N2 is the second section, BC section. So BC section, I just cut this through. Okay, I want to see the internal force in the BC part. So I just cut it and then choose bottom side. And then we adding the N2, which is which is we don't know what is. So this is N2. N2 and PC. So N2 minus PC minus PD equal to 0. So N2 equal to PC plus PD. No problem. In your direction, in the sense, in the direction you assumed. Okay, and then M3. M3, we are going to see the third section. So we just cut it, and then we do. Okay, M3. And M3 and PD will be M3 minus PD equal to 0. So M3 equal to PD. Okay, so after these three, I know the value N1, N2, N3 under my assumption of their upward positive. So if, because we know the value when in a real problem, right? So we know that after they do that, we have positive, which means that our assumption will be correct. Or if this is minus, we will the direction will be opposite. Okay. So N1, N2, N3. This is the internal force within that section. So delta 1 equal to PL divided by EA, right? P is N1. N1 L1 divided by EA. N2 L2 divided by EA. N3 L3 divided by EA. So everything summing up together become this. That's it. OK， 听得懂吗？好，我们要把每一段都把它算出来，每一段的伸长量都要算出来。可是每一段的伸长量就必须要先知道每一段的内力是多少。那要看每一段的内力是多少，我们就从这边切过去，切过去完留下来的，你就来做力平衡。那我这边上面跟下面都留下来一次，然后给你们算算看，结果发现答案是一样的，对不对哈？那为什么你会觉得这两个值好像是差一个负号啊？对，因为这两个本来就是到最后要把它接在一起会抵消掉嘛哈，所以上面跟下面的确会差一个负号。OK， 好，然后接下来我们就不管它啊，我就以后都留下面啦哈，也不是啦，这一题就留下面，好，然后我就留下面就可以把 N1、N2、N3 内力都算出来以后，再代入它的公式 delta。每一段的 delta 都算出来以后，全部加总起来就是全部的 delta。OK， 简单。Next one, bar consisting of prismatic segments. So all will become more difficult. Okay, which means that not only the force, but also the cross section is different. But actually, the same. Okay, they are the same. So PA, just like a tower. Okay, PA on the top, PB on the top, and E1 is, which means that the Young's modulus of the material 1, Young's modulus of material 2, and then if we want to get the total deformation, total displacement, we need to obtain the deformation for each part. Okay, so each part need to get the internal force for each part. So I just delete and sort of cut it for the first one. And now this page I left upper part. Okay, so PA and N1 should be the same. Okay, PA minus N1. Sorry, minus PA plus N1 equal to 0. So N1 equal to PA, no problem. And then next we cut. Yeah, this one, if we cut that, and we left the upper part, and then minus PA minus PB plus N2 equal to 0. So N2 equal to PA plus PB. That's exactly what we written here. And then we can have N1, N2, and then we can have delta 1, delta 2. Delta 1, delta 2, N1, L1, E1, A1. So for the first section, N2, L2, E2, A2. And then we sum it all together. So if we try to write it down systematically, we can have the summation and I equal to I is the definition of I is the section number. Okay, so NILI divided by EI summation together will be the total delta. Easy, right? So if you have this one, and then you can extend this for the prismatic segment. How about this segment shrink to infinitesimally small? So here, the tau is really, with the segment really small, really small. So imagine that this one is actually is the cone shape, right? So what you need to do is one section, delta I equal to MILI divided by EIAI, and total elongation will be the summation of them. How about this one? Actually, this is really similar. What you do is the elongation of small slice d delta, and mi is actually the n of x. N is a function of x, so the force can be described by the position of x. Okay, so nx dx, because the dx is really small, dx. Okay, it's just like this. So this is actually exactly the same thing. And ei, I'm sorry, I should write it down as, oh, it should be ex. So it's a function of x. So everything become function of x, n x, e x, a x. Okay, so when you do the integration for this, I should write it down like this. Ex. So when you do the integration, all you need to do is find the function of n. Sorry, the n which is function of x. Need to find Young's modulus as a function of x. Area function of x. Okay, and then do the sum, do the integration, and you can get total deformation value. 这其实蛮简单的哈，就是刚刚你如果可以，那某一小段都可以接受的话，你就想象那些小段都变成极微小的 dx 的厚度，那不就是把 summation 变成积分嘛？好，然后呢，每一段的 n 就把它写成 n 对于 x 的函数，每一段的杨氏系数就是1对 x 的函数，每一段的 cross section area 截面积也把它写成 x 函数，积分就好了。好，没关系，看起来好像很复杂，你只要大概懂，等一下有一个例题就可以直接帮助大家来写了哈。OK, so next will be the example. Oh, it looks really complicated. So let's describe this. L1, L2, A1, A2. L1, L2, A1, A2. Okay, and E is 200 gigapart. Okay, so this one is 200 gigapart, and A equal to 700. What is A? Oh, A is 700. B is 625. And P1, where is P1? P1 here is 10 kN. P2 equal to P2. Okay, P2 equal to 25 kN. And assume being BDE is rigid. Okay, rigid. Okay, so this yellow part will be rigid. So it will help us to get more information on it. Right, so now let's take a look. The problem asked me to determine delta C. So which means that it needs us to calculate this bar, total deformation, right? So we need to get the force here, and because it must have some reaction force here, and also force B, either downward or upward, I don't know, and obviously P1, of course. So we need to get the force at B and force at A, right? So how can we get this? So if we want to get this force, we just cut it. We just cut it and we leave the first part and the second part. So what is the first part here? First part, BDE. Sorry, I should put it B, D, and D, E. Okay, and this is point E, this is point D, and this is point B, and then you will have force P2, right? And D, okay, D is a point that just pin there, and should it should be it should be like this and that, right? But there's no left and right force, so we can know that this one will be 0. Okay, so we just take it out because there's no horizontal force. So of course there's no horizontal force reaction. Okay, so we only need to consider the reaction force in D, so RD, reaction force D, and we assume that upward, okay? We assume that, we don't know yet. And B, PB, we don't know yet, we assume upward, right? So now, let's take a look. Sigma, sorry. Sigma M B ND lah, ND equal to 0. So let's take a look. PB times A is the moment. So PB times A, oh, I forgot to write down, this is A, this is B, okay? So PB times A, PB times A, and rotate about the point D clockwise. So it will be negative, right? And P2 rotate about point D clockwise. So it's also negative. P2B equal to 0 and PB equal to minus P2B divided by A equal to minus 25 times 625 divided by A 700. So EB equal to minus 2.3, sorry, 0.3 Kn. So notice that minus. So our PB's assumption will be incorrect. Dun dun. It should be like that. Downward. Okay, downward. So in a real plot, this one should be downward, upward, downward. Okay, it's real. This is like a calculation procedure. Okay, and then how about, so now we know that this point, let me take a look. Okay, this point will give the PB force downward in BDE BDE bar. So the B attached to this bar, it must has This is A, this is B, this is C, and then you have a C is P1, and this is RA. We assume that upward, right? We assume that. We don't know that yet. And then, okay, careful about this. We know that this point in this part, this B is downward P3, or we can say PB. Okay, P3 or PB. PB lah, PB. Okay, PB. Okay, PB. B. Okay, so in this part, PB is downward. How about in in this bigger bar, vertical bar? It will cancel each other, right? When you attach these 2 points, they become internal force. So they need to be the same value, but opposite direction. Okay, so be careful about this. They need to be, cancel each other. So let's take a look. Sigma Fy equal to 0. Ra plus Pb minus P1 equal to 0. Ra equal to minus 12.3 Kn. Kn, okay, so you see minus again, so which means that the assumption was wrong, okay? But it's okay. We know that in a real diagram, this one is P1, this one will be PB, B, okay? And RA will be downward, okay? Downward, right. So now, you have all the external force, applied force on bar ABC, the vertical one, okay? And then you can imagine that this one is actually something like this, right? So just do what you do. We just do what we taught in the previous few slides. So let's take a look. What to do? Okay. Delta So next section, delta C equal to sigma N I equal to 1 and MILI EIAI EIAI. Okay, so it will be okay. So this one will be, we want to find the first section. So what we did, what we're trying to do is okay, we cut here and we left upper word, okay? And if we cut this card, we left bottom word, okay? It's okay. I mean, you can do whatever you want, but to me, I will try to make it easier, okay? So now the first one. The first part, green part, okay? And this is RA, and this is N1. Yes, and I want to get what is N1. and you see RA, now I already know that RA direction is correct, right? So it must be compression. Yes, because RA direction is, we are sure that is correct, and N1 is upward. Okay, so this is a minus. Okay, a minus, and the force will be 12.3 times 10 to 3. 12.3 kN, right? L, 500 times 10 to minus 3, and 200 times 10 to 9 times 160 times 10 to minus 6. So this is the first part, right? And the second part will be this one. Okay, and you have E1, and this will be N2, upward, and also P1, we are sure this is correct direction. And then we know that it will be tensile, tension. Okay, so it must be positive. And 10 times 10, 3, 750. 10 to minus 3. Yeah, and this one, 200 times 10 to 9, 100 times 10 to minus 6, and it will be this one, and you know that. Okay, and the result will be minus 12992 times 10 to minus 4 plus 3.75 times 10 to, how can I do that? Need to move the upper. Wow, it's pretty difficult. Okay. Minus 4m and equal to 0.183 millimeter. Okay, that's it. So you know that this is a little bit complicated. However, if you do it separately, everything will be all right. Okay? Understand? Understood? It's okay? It's okay? Do you need my Chinese explanation? I think it's okay, right? There's no new concept in this example. All we need to do is that we reverse this problem. He asked us get the deformation at this point. So we need to know each section, internal force for each section, section. And then because we don't know the B, so we need to use other part to help us to get B and PB. The PB will be the most important part is that PB for this, and I mean two parts need to be cancel each other, so the direction will be different. Okay, see different. This one, these two should be different with the same value. So that's the most difficult part, I think, in this example. All right. Any questions? Okay. Oh, Oh, another important part is that you need to see this is compression or tension. This is a little bit I mean this is easy, but you need to understand this because RA is the direction of RA. You know that this is correct. So N1 must be counterpart of RA. So this you can see this is compression. And P1, you also know that. So N2 is also is a tensile. So you see that I cut it. I choose upper part and bottom part freely. I can choose anything I want. If you want to check if this is correct, you can use this part for the compression and that part for the tension. Okay, so everything's okay. But all you need to do is that you need to know, you need to do that systematically. You need to follow the same rule. OK， 这是很重要的哦。你要依循同一个标准，不能说，左边，然后你假设它是上面，然后右边假设它下面，就是有点怪怪的。你必须要 follow 一样，遵循一样的流程，那这样的话应该都是不会错的。Okay, so that's it. So this is the first example, and next one will be related to the integration. Okay. 最近在读一本书，叫做多巴胺国度》，有听过吧？好像有同学有点头。多巴胺国度好像是一个史丹佛心理学大学心理学系的教授写的。他告诉我们一件事情，就是说为什么忧郁症成为现代的文明病？为什么就越来越多的忧郁症，然后或是忧郁这样？那我也有发现这件事情，就是古早的年代，就是生活过得很困苦的年代，然后大家都没有忧郁症，反而现在我们过得很富足，反而有忧郁症。那我看了一些书，那我有一些自己的体验，然后我自己得到的结论就是，其实人呐，多多少少都有一点 M 属性，就是要自己自虐，要自虐你才会能感受到开心，这很神奇的一件事情。呃，对，这就是神奇哦。那我自己也有觉得说，人在世界上就是要受一点苦，好像目的就是这样子，就是你要来那边受苦，还蛮奇怪的。那可能就是要修炼吧。那所以如果今天就过太爽，你的身体或者你的脑袋就会不要让你过那么爽，所以就让你忧郁。好，那这个其实还蛮特别的。所以，但是我跟你说，什么自虐啊，什么事情那种自虐，请选择好的自虐，好吗？例如说去跑步，例如说去做运动，把你自己操得很累，然后你这样就可以让你的身体还是学得会如何享受乐趣，就才开心的起来。为什么吸毒的人是无法感受到乐趣的？因为他那个多巴胺的那个分量啊，就是太超标了，所以你吸了毒以后，那个那个多巴胺太多，你就会再也感受不到什么事情可以让你开心了，所以就会超级忧郁。这样，那所以这就是为什么毒品不能碰的原因。那其实很多事情，其实人会难过，其实也是因为之前的多巴胺让我们太爽了，这样，然后这个社会或这个生活让我们太爽了，然后我们就无法体验到平淡的快乐，然后我们就丧失了快乐的能力。对，这是个书上写的啦啊，然后我觉得哇，好有道理哦。 那后来我想说好，那我就慢跑的时候，我以前就是慢跑，慢跑就慢跑而已，然后没有想要虐待自己。那现在看这本书以后，我在慢跑的状态之下，我就会来虐待一下自己。例如说爬坡的时候，我就用冲刺的，然后冲到顶的时候，我都快要死掉了，就啊，好累，好累，好累。那好像有点笑，就是跑完以后就觉得哦，好爽。对，就是虐待自己完以后就好爽，这样，哎，很神奇吧？啊，这个是一个很奇怪的事情，这是我最近的体验，这样。呃，你知道那个生涯规划吗？不是杨老师常常都会叫我去讲生涯规划。生涯规划我在近几年讲的东西，我添加一些新的东西在里面。就例如说，我已经来这边10年了嘛，前8年，我就是过着那种人就是要积极啊，正向啊，怎样怎样怎样啊，然后就是不要气馁啊，然后怎样怎样，积极乐观啊。那时候我是这样子，那是因为那时候没有遇过挫折。跟大家讲一个就是蛮不好意思的事情，就是大概在40岁以前，我都没什么遇到挫折，就是我就是努力我就可以得到我要的，努力我就可以得到我要的，努力我可以得，但是在40岁以后有发生一些事情，然后我就会发现有些事情你再怎么努力都是没有用的。好，那你就会发现人的无力感，然后就会造成一些忧郁啊或什么什么之类的。那所以我才开始去看这些书，然后去才知道忧郁这件事情是需要去面对的。所以我的生涯规划跟大家跟之前你们的学长姐分享，我都说大家要努力，大家要加油啊，努力啊，乐观啊。但后来想不对，这些东西如果在对于忧郁的人来讲，这些都是屁话，根本没有用。那所以我后来就在那边加了一些，就是说后面就开始讲一些，如果今天遇到呃忧郁的状况的时候，我自己是怎么做的这样。那结果很有趣的一件事情就是，当我第一次做这件事情以后，前8年在讲这些积极进取的，讲完以后大家就拍拍手，好，我就去下台，我就结束了这样。然后结果没想到我在前2年做这件事情，就开始讲一些关于忧郁的事情的时候，讲完以后下课，好多人跑来找我的。看来这件事情真的是有问，就是真的是大家会遇到的问题，就是太积极正向根本没有一点用都没有啊。那反而他们就来找我说，哎，老师，你之前讲的那件事情，就他遇到一些问题，然后就问我，然后我就跟他分享，然后我不知道之后有没有对他造成帮助了哈，但是这表示说，哎，对啊，就是蛮有趣的事情，嗯。就人活到一种程度以后，对，就会遇到一些无力的事情，这是很正常的。Anyway，跟大家分享，OK，so what I just told, I just read a book about why people get depression easily nowadays because our brain will get used to uh, some some impulse that make you feel really good, like your internet social network, and then like a drugs. Okay, so it's like an internet drug to make you feel too good, and then lose the ability to enjoy the small happiness. So we will lose the ability to be happy. So uh, and then I did some experiment to myself that I do some slightly good torture to myself, like run to death. Uh, yeah, so run, jog, and run really, really fast to torture myself. And then I found that yeah, it really works. It's really interesting. So then I just share all these stuff in my uh, course, just like what I did now. And then I get more response from students. It's really interesting. Anyway, so to torture yourself in a good way, okay? And then it will make you happier. All right, so next, find delta, elongation of the bar. If the bar is, the cross-section area is gradually changed, okay? P, and then the area is circular, okay? Circular. Okay, this is circular cross-section, and the top surface will be dA, with the diameter dA, and the bottom surface is dB, and then fixed on the wall. And the diameter in between, we call it function of x d, okay? Function of x d. And let's take a look. So if we want to get the elongation of the bar, we need to know that, because elongation for each small segment will be the integration, right? So it will be related to MI Li over EI, right? But the AI is changing. Okay, so we need to find the relationship between A and X, right? Because we want to find A of X, because the cross-section is changing, right? So AX, we want to find that. Before we find that, we need to find dx. So that's exactly what I wrote here. We want to get how diameter change varies with the x direction. Okay, so let's take a look. So there's right. So I will see you after 10 minutes. If you have any questions, just let me know.来，请说。
往上嘛，要不能往下。
哎，没有，那个 PB 是我给的，是外面的人给的。
哦，所以他已经在
定
B 点10。
对，哎。
下面这个他为什么只是求 C 点，那还要算上面的 A？是因为它整个会一起生长。
哦，对啊，因为 C 点往下走，如果今天 A 就上面那一段没有动，那对，但如果上面动了，它已经先往下，然后再算下一点，所以 C 点的位移是全部的。嘿。
我在这边，你刚刚写这个方向可能是向上，
对，
可是然后这个点的话，那我们假设要向上了，
对，
你只要看它 bar 的话，它上面内力的影响，上面应该是向下。
应该这样讲，我这个橘色这个部分是我用另外一个方法算，也就是说，我不是说切的话可以留下面或留上面嘛，那下面的话，当然就是我留下面的话 ，N1 当然就是往上。但是我如果今天不做下面这个东西，我直接算这个，我还是会假设往上啊。我 N1 还是会假设往上。然后只是我们算出来的答案以后，我们可以知道 N1 它真正的位置。我这边真正的方向，我下面用另外一个方法算，我也可以算出 N1 它真正的方向。所以这边只是说假设而已，这两个是分开的。对，到最后它答案一定都会是相反，然后 的答案，对，你知道嘿。
那个我讲就直接后面的地方，这没关系，那都还在桥下。好像是描述的。下一个。
你说这个可以在桥上，
对对对对。
这下一个都是对。
现在看也不错了，可能看到那些看才比较久。
哎，对，周天。
因为我不知道我是这样讲，我是那个230个人每次去。好味，好味。而且这个气氛，我刚才在一个好味的，好多。
为什么是你们看起来？也不是他这跟一个是他一起觉得好像。
大学的很多
有一个
他
怎么样？
他这个是吓死我，当时。这个好玩的，
我现在怎么了？觉得
但我那个画面想出来了，又成上一个，也在练仿佛那个已经
去了。真的去那个三天机场。你想有？
我们要先查一下，再对，更查再说。刚开始那个大家都跟猜，没习惯的知道，做不习惯，不知道知道。还是他们特别优秀。但是招我跟你讲，就是
哎，这也不是，毕竟是觉得。
你这样有在你上这个一些器材之类的，所以那你看是种，所有东西。
给那个是个对付，那个就是 然后这个太晕了。
我在看上去嘛，那病的啊，所以我就是一个这里。你现在的时候，现在这你现在是对好像有不一样，他会怎么非常发现？另外一个这里的几个子弹，这样子的，他是要想。不是吧？不是吧？
哎，罗老师找我啊。我跟罗老师是很好的朋友。对，对，罗有学老师，可能是因为我们都是计算材料科学的，对，我们做模拟的，然后跟实验就不太一样，所以我跟他讲话都还蛮像的。你知道我跟他有一个很有趣的共同点吗？我是跟他走路，我发现果然这就是计算材料科学人才会做的事情。就是我们走在路上，尤其是那个旁边那个走路啊，哈，你有没有发现那边的都会有砖块，然后一条线啊，砖块一条线，对不对？哈，我跟他都是这样，我都不会这样，我都不会，我们都不会这条线。我走路的时候我就会这样，哎，然后我还特地会调整我的脚步，然后就不要踩到那条线。我不知道为什么，哎，我跟他都会这样。你有没有发现自己也会这样子？有哦，你也会啊？你要不要来计算材料科学？对啊，我后来就觉得，哎，为什么我会这样？就是不愿意踩到那条线，明明也没怎样，但就是对，为什么？为什么？那请问踩到那条线，就不会踩到那条线的是大多数的人吗？还是少数的人？还是说从来没有注意过？没有注意哈，没有注意就是会踩到，但有注意的就是不会踩到，这样。还是说有人注意到了，还是踩过去？那这也是 我其实蛮想要学习这样的，就是注意到了，但是还是踩过去，因为这表示说你选择自己不要去理会自己想太多的事情，对不对？我还蛮希望我自己也可以这样子的，因为我已经想太多了嘛，我天生就是这样子的，所以我希望我自己不要让自己那么烦，这样。哎，anyway，哇，怎样怎么讲？I just describing I think the personality of the simulation guy. I don't know. I won't step on the border of the green boundary, maybe. Okay, I don't. Maybe you don't understand what I'm talking about in English. Anyway, it's not important. So now let's find the d of x, and notice that the d of x is different from dx. These two are different. You notice that, right? dx is the thickness of the segment, okay? But d of x is the function of diameter varying with the x coordinate. All right, so these two are different. So please be careful about this, okay? Now, let's take a look. So how can we get the relationship between a and x, or diameter of x? Let's do similar triangle again. This, well, anyway, draw by myself. Wow, no. Okay. Really examine my drawing ability. Okay, two similar triangles. If we extend from A to point O, the O is the focus of the slope. Okay, so intersection of that slope d of x to the A will be the x to LA. Okay, you see, x and LA will be the ratio between them will be this one to that one, right? So now we can get d over x, d of x, x dA divided by LA, and A of x equal to pi dx square divided by 4, and equal to pi dA square x square divided by 4 LA square. Okay, so A of x, we obtained that. It's good. How about delta? The delta, of course, will be related to the integration. Integration n of x dx divided by e of x, a of x. And don't worry, n of x is easy because there is only one p. And here is all of them are the same material. Okay, E. And of course, A will be substituted into this place. Then we will do the integration. Integration P divided by E pi dA squared x squared divided by 4L A square and that one and dx. Okay, there's a really important thing here because what we are going to integrate is this length, right? So it should be x is from here, right? The origin is here, but the actual integration path should be LA to LB. So should be really careful. LA and LB. Okay. Then, then equal to 4PLA divided by 2 divided by IEDA square LB LA 1 over x square dx and equal to, okay, this is really big value. It's a constant. So I just write it down. C LA minus 1 LB. Okay. CL divided by LA LB. Okay. And equal to still 4PL divided by pi EDA square. Just saving some time. LA divided by LB. So, 4PL divided by pi EDA square dA divided by dB. Oh, so you can imagine that this one is actually equal to that one, right? LA divided by LB. LA divided by LA divided by LB actually equal to is a dA divided by dB. So they have the same ratio. Maybe you think why we cannot using this as an answer? No, because LA is what you created. You created LA. The LA is not in the problem. So the problem won't know LA is what kind of value. You just created that. So you need to transfer your LA, LB into DADB because DADB is provided by the problem. LA, LB is created by yourself. Okay, when you are doing this similar triangles. Okay, so careful. And then equal to 4PL divided by pi EDA dB. Okay, so this is the final result. And this is really interesting thing. I want you to check. This is the result, right? This is the answer. There's a really interesting thing. You can check when the A equal to the B, sorry, the A equal to the B, which is D. What is delta? What is delta? The answer is EL divided by EA. Okay? When you substitute DA and DB, all these, and then you can get delta equal to PL divided by EA. Wow. So, which means that this is more complicated problem. and then you make some special case, and then you can return the one we just told. So which means that this answer must be correct. So this is an easier way for you to check the answer you obtain is correct or not. Okay, good. Here I think the calculation itself will be more difficult than the concept because there's an integration, and then yeah, I know this is really difficult, but the concept itself is, I guess, it's okay. All you need to do is just find the function of x, the material, area, or force. Okay. Yeah, that's it. Next one, next chapter, next section of this chapter will be really difficult. Really, really difficult. It's called statistically determined or statistically indeterminate. 静定,静不定. Okay. When I was your age, I found this one is really difficult. I will try my best to help you to understand that. Next one. 但我还是觉得很奇怪，就是为什么我说，哎，要不要加入计算材料科学人，大家会那么担心、那么紧张呢？对我来说，要加入实验团队，我还觉得才比较紧张，因为我的手很不巧。我以前曾经加入过实验团队，然后我们要做电性的测量，然后我要弄那个压电材料，我要抹那个银漆，然后抹上去以后，我就烧坏了那几个，我就连续烧坏好多个 sample， 我大概害我的老师损失了大概至少有5、6千块吧。我对不起他，因为我的手就是没办法很巧，就是弄一弄，那个银漆就会跑到边缘之外，然后它就造成短率，然后每次一接啪，然后就一条黑色的线就在上面，都是我的错。那如果是模拟的话，你看多好，我就用3D 的建造，哎，什么 coordinate x 等于多少，y 等于多少，噔画出来，银漆我就直接下说啊，这个面是银漆，绝对都是100%的在那里面，就不会。然后就算是烧坏了也没有关系啊，我再重新 reset，就好了，好，然后也不会花老师很多钱啊，这就是我觉得，这让我觉得很安心啦，哈，我运用的是一个虚拟的东西啊，没钱坏了就重来一次啊，那感觉起来很放心，这就是我喜欢模拟的原因。哦，模拟最大好处就是你可以在家里连线到学校的电脑，你可以在家里做事情。你知道我以前在英国在念书的时候，当然也是做模拟嘛。我是出去玩，然后拿着手机，那时候手机是 iPhone 4，iPhone 4，然后我就那才那么小，我就用那个去连线回我的办公室，然后就那边执行我的程式，但是我已经出去玩了，好跑，然后我就出去玩，跑我就睡觉，你看多好，我就边出去玩，然后边跑边做实验。但如果今天真的要做实验的话，你就一定得在实验室。好，这就是我最喜欢模拟的地方。好了，不知道大家有没有被这个广告吸引？好，OK，next one， statically， 哦，那 statically determinate，statically indeterminate， 静定静不定。OK，so statically is that the problem you've encountered so far is all statically determined because you can obtain all the reaction force unknown by using force balance. For example, this one, that one. Okay, this is statically determinate because you can obtain the force unknown by using force equation. But if we have extra fixation, extra constraint, if you fix this bar, these two bars, between the ceiling and the floor, So which means that the RA is no longer the force. RA is the reaction force. RB is reaction force. T is your load. So you have two unknown, but you don't have enough equation, enough force equation to get the unknown. This is statically indeterminate. Okay, so more unknown, one unknown. So force equation can help you to obtain unknown. But now you cannot have one. How can we do that? As we said, the God close the door for you, it will open a window for you. Okay, so we need to use geometrical relationship. Geometrical relationship. I will tell you later. This one is typical statically indeterminate structures. Okay, so RA, RB, okay, and B is here, right? So again, we want to solve that. Balance equation. Well, grammarly incorrect. Force balance equation. Anyway, okay, force balance equation, sigma Fy equal to 0. So you know that Ra plus Rb minus P equal to 0. That's exactly what we written here. And however, I, Rb are unknown. So we cannot solve this. We need one more equation. One more equation. So what will it be? Compatibility equation. Compatibility means that you need to fit the current status. 它必须要符合现状。Okay, fit current status because now it is constrained between the ceiling and floor. So the delta AB need to be 0, right? Because they fixed. They must maintain this condition because you fixed on the ceiling and on the floor. So there's no total deformation for this bar, right? So you see, because you adding one ceiling extra ceiling, so you have more unknown, but it also tell you something about the deformation, because the deformation has been fixed, has been limited. Okay, so it provides another equation. It's called compatibility equation. Delta AB equal to 0 is this case. You may have other case depending on what kind of constraint you added. Okay, this is not always the case. Okay, please don't memorize this. This may change according to the boundary condition. OK， 不要死记这个，这个是因为你把它定在天花板跟地板，才会有这样子的式子。如果你有别的束缚方式的话，可能不是这样子哦。等一下会有例题。OK, so this compatibility means 中文相容性。Okay, so let's take a look. So we know that delta AB equal to 0, total deformation equal to 0. So again, we need to write down just what we did before, because we want to know each section, deformation for each section. So here, first section. Okay, and this is RA, and this will be an AC section, AC segment. Okay, or this part. Okay, and this is RB, and this is NCB section. Okay, and then delta AC section. AC is RA times A divided by EA. Okay, delta CB, you assume that this is positive. I mean, you assume RA, RB are all positive, right? And in that condition, you assume that this is correct because you cannot get the number. If you have number, you will know the actual value or direction. But now you only have symbols, so you don't know if this is correct. It follow your system. So no matter how the value is changed, this is okay. Okay. So RA is upper part, and MAC must be tension. So this is positive. And if RA correct, RB correct, NCB must be downwards, will become compression, so it's negative. So maybe you will know, you will ask, are you sure this is positive or negative? We are not sure, but we know that delta AC and delta CB are different sign. We are sure about this, okay? But we don't know which one is positive or negative. We don't know that yet because we don't have the value. But we are sure they are counter sign, okay? And then if we have this RBB, for RB is NCB, right? So RBB is for this length divided by EA and summing up together. And after summing up together, it need to be equal to 0. So these two equations can help us to give the unknown solution RA, RB. Okay, that's it. 好，这边可能同学会问说，哎，老师你怎么确定这边是正的，这边是拉，这边是压？其实我不确定哦，我只是就是假设它往上 RB 假设往上，那至于谁是压谁是拉，我真的不知道，必须要看这个 P 的力是多少。必须要看这个 P 是这个值是多少，这个 P 的值是多少 ？OK， 那如果今天这个值是负的或什么之类的，那它可能就会变号。但是唯一可以确定就是我确定这两个人他是不同符号的，因为我就是照我这样的逻辑去立平衡嘛。反正只要有其中一个人变号，那他就一样也会照着这个逻辑去算下去。所以这边是正，这边是负，不代表这边就真的是拉，这边是压。那如果这边的一带进去，哇，它是负的了，那这边就会变号啦。那反正他们两个一定是就这样子的看来，他们上下段，他们一定是相反的号，好，相反的号。那谁是正谁是负，要真的带值才知道。反正加起来就会等于0就对了，这样哈。那这边可能就是需要思考一下。Okay, but the main concept is that we using force balance equation and compatibility equation. Two equations help us to determine two unknowns. Oh, that's the main concept we taught in this page. Okay, so here will be the given material C and S. There are two materials, C and S. Okay, and area AC, area AS. And then we have a force applied to a thin glass, maybe, and we will ignore this one. We'll ignore this, okay? We just focus on C and S, two material in the middle, okay? And then we want to find the compressive force for PS and PC. PS and PC. So, and also we want to know the sigma S and sigma C, the normal stress in S, normal stress in C. S and C are material, right? C and S, okay? And delta is the deformation, okay? Sorry, should be this one, deformation. After we apply for AC, EC, AS, ES. Okay, so this is a little bit difficult. So let's explain this. All right. So the first one, equation of equilibrium. Okay, force equilibrium. So what is the force diagram? You can imagine that the force downward, and then it must can if you want to see the internal force, we just cut it, right? Remember what always said. We cut it like this, and then we will have two part, upper part and lower part. Okay, upper part. What is upper part? Upper part is P, and it must, this glass must have obey force equilibrium. So you can imagine that this is, it must has PS, the force from the S, and the force from the outside. Okay, so there are two force to resist the pressure from the force from the P. The first one is PS, the other is PC. Although it looks there are three. No. This one and that one are the same one because they are a circle. Okay, so PC and PS summing up together equal to P. And you can imagine that this force should be that, and of course, PC will be opposite direction, the same value. PS opposite direction, the same value. Of course, you can see that sigma Fy equal to 0, so minus P, of course, minus P plus PS plus PC equal to 0. First equation. Okay, I guess you know this one is from here, right? Because negative, positive, right? Negative, positive equal 0. Now we have two unknown. We need to get equation of compatibility. Okay, so what is the compatibility equation? Oh, is that delta equal to 0? No, right, you're right. So you see, you do the compression, it must have some delta. So what is the difference? What is the equation? Because you are using the same plate, so you will have delta S and delta C, which are right, because you press together, right? So you can imagine this is a really complicated problem. If S is more stronger than C, which means that S will provide more force, resistant force. So they were balanced. This is there exists a complicated balance between these two materials. So this is too complicated. We cannot guess. We need to use systematic way to solve it. Okay. Right. So delta S equal to delta C. So now, see, equation of constitutive. Okay, equation of constituted. What is constituted? Constituted is but go. Wow, there's the translation doesn't help, right? But go. Right? 哎，我有没有写错啊？go 要怎么写啊？当你看一个字，你会发现看一个中文字看久了，你就会发现它越来越不像那个字。有哦，我小时候我有发现这件事情，然后我发现别人也是这样讲，哎，好奇怪哦。然后我觉得，哎，这个字哪里写错了？很神奇。Okay, what does that mean? But go or constitutive is actually the relationship between the stress and stress. Stress and strain. Is a relationship between stress and strain constitutive. Okay? 就是应力跟应变的关系，就是本构方程式啊，我也不知道他为什么要取这么可怕的名字，但是反正它就是 stress strain 之间的关系。Right, so what is stress and strain relationship? Come on, stress strain relationship. Stress strain relationship. Conclusion, this one. Okay, so let's connecting delta S and delta C together. So delta S equal to PSL EA ESAS. Delta C equal to PCL ECAC. So this is equation 2 and this is equation 3. Okay, so from 2 and 3, we can get PSL ESAS equal to PCL ECAC. Okay, and we now know that so the first one, compressive force, PSPC. So PS equal to, PS, we substitute the relationship back to the force. PS plus PS ECAC delta. Sorry, divide by ESAS equal to P. So PS equal to, wow, very long writing. 1 plus ECAC divided by ESAS equal to PESAS divided by ESAS plus ECAC. Okay, so that's it. So PS obtained. How about PC? PC, hey, I copy and paste. Okay, and then I can just change ECAC. Well, you need to substitute this one back here. Sorry. Oh, you need to substitute this one back here and to get the PC, and you can get this one. And then I will tell you, after you do this, you find that, oh, they are symmetry. Their answer looks symmetry. When you find that symmetry, which means that your value will be correct. Okay, it makes sense. It makes sense, right? So PSPC equal to has this kind of formulation. And the second one, sigma s. Well, you just divide by AS. Sigma C, you just divide by AC. Okay, so I don't just write it. You just, well, okay, that's it. And the third one is also easy. Delta equal to PSL divided by ESAS equal to what? Equal to PL divided by ESAS plus ECAC. Okay, so that's the result. Okay. Again, when you write down your answer, you always can check if this makes sense. If this makes sense or not by checking the symmetry of so ESAS, ECAC, and PL delta. This looks really symmetry. It's quite nice. And this one also looks symmetry. Nice. Okay. So this problem, the main part of this problem should be this one. This one is the most important part. You need to know how to write down the force equation and the correct compatibility equation, and then linking the delta to the force, okay, constituted, and then everything can be solved. Okay, right. So now you are become you become mechanicist, mechanicist, 力学大师了. Okay, you see, this is a really difficult problem because this is really complicated. Two material and their force need to be shared. Stronger material share more loading. This is the softer material share lower loading. And this is really complicated, but now you have a systematic way to solve it. And you are really different from what you enter this classroom 2 months ago. Okay, very good. 好，我觉得我觉得蛮厉害，就是你看这个材料，不同的材料，然后它会分担它的力，那这其实很复杂哎。但是你现在会了，你现在用一个很系统性的方式去解它，哇，那真是一个还蛮厉害的一件事情。Okay, next one. I will wait until you finish the writing. 我跟罗老师，跟你讲，罗老师，我第一次跟他成为好朋友的时候发生的事情，就是他刚来，然后那时候我也蛮菜的，那所以那时候我们2位就被就是系上说，来你们去跟中钢交流，要 present 一些你的工作等等的，然后我就跟黄尔文老师我们3个都是当时就是比较新进的老师，就是去中钢去介绍我们的研究这样，然后我们去搭高铁， 然后我就跟他约在高铁见面嘛，然后我们3个就要一起搭高铁去。然后那一天他就来到那边，然后我就看他愁眉苦脸，他觉得很难过。我想说，怎么了吗，罗老师？你还好吗？然后说他整晚没睡。我说为什么整晚没睡？你知道前一天发生什么事情吗？前一天好像有一位学生就是自杀了，新闻跟他没有关系。然后他就说他看到那个新闻，然后那个学生因为什么课业压力啊什么什么之类的，然后他就自杀轻生了，然后他就很难过，一整晚没有睡。然后我就这时候我看到他讲，然后我就觉得他那个头的上面有那个光环，你知道，就是那个，哎，我真心这样觉得。我说哇，你这个人后面也太善良了吧！就是他真的是为了这件事情，然后很难过，然后就在想为什么这件事情会发生，然后你也知道他为什么会跳过那个线不踩吧？他想很多，对不对？那我都没有，我当然看到那个新闻，我当然也很难过，但是我就没有去让他就是让我自己睡不着觉，但他真的会为了这件事情而睡不着觉，然后我觉得他真的是很善良的一个人。那然后后来我就跟他聊天啊，然后觉得他就是他真的是一个很善良的人啦。那虽然他因为他太善良，所以有时候他可能讲话会太直接啊什么什么的。但是因为我了解他，所以我知道他心地是个很善良的人，所以有时候他讲话呃有的时候可能会太直接的时候，我也不会觉得怎么样这样。但可能有些人会觉得怎么样啊？那就是有时候我会提醒他这样。那总之他就是一个非常善良的人哦，光环。我真的是我每次跟别人讲到我跟他认识的经过，我都会讲到这件事，就是我就觉得哇，散发佛的光环。但没关系，但我只是觉得说很有趣啦。哦，他真的想很多。那还是很努力的想要把就是教育啊什么做好，然后我觉得他真的很棒。那所以我才跟他蛮好的这样。那 OK English Professor Law is a good person like a Buddha like Buddha. Okay, he's really pure pure pure. He's thinking too much. He's thinking too much. 慈悲为怀好难翻译哦。Okay, next one. Um, E and E1, E2. What is E1, E2? E1, D1, L1, E2, D2, L2. So the material with the deformation is this line, okay? This line, not this one. This blue part is rigid, okay? So rigid. Ta-da. Okay, so the material which deformed is the black line, okay? Careful. And then you have a force here. E, E, okay? And of course, L1 and L2 will has the force on that point. So if you want to see the internal force, we just cut it, right? We just cut it, and we assume that T1 and T2 are all positive, okay? And then RA, R1, sorry, RHRV will be this one and that one because it is a pin, but because there's no horizontal force, so it will be 0, okay? So we actually won't plot this one, okay? So equilibrium of equation, equilibrium, okay? Summation MA equal to 0. So T1B to A, right? T1B counterclockwise, positive. T2 counter plus. P clockwise minus. Okay, so T1B positive, T2 2B positive, P3B minus equal to 0, and T1 plus 2T2 equal to 3P. Okay, T1 plus 2T2 equal to 3P. Done. Next one. B, equation of compatibility. Okay, this one will be a little bit complicated. We need to find the geometry relationship, right? So because AB bar will be rigid, so if it change the term, okay, it must maintain the straight line. So delta 1 and delta 2 must maintain this straight line. So another similar triangles. So what is the similar triangle? B, delta 1, delta 2. So the similar triangle here will be 2 delta 1 equal to delta 2. No problem. Next one, equation of constitutive relationship. Okay, so delta 1. Delta 1 must related to the length, the changing of length of L1. The changing L2 must be delta 2, right? So we can write down delta 1 equal to T1 L1 divided by E1 A1. So because it's too complicated, can I make it blue? Okay, the next one will be delta 2. Delta 2 equal to T2 L2 divided by E2 A2. So I will continue this lecture tomorrow morning. Okay, that's it. See you tomorrow. All right, thank you. If there's any question, just let me know.啊，第二个颜色，哦，画反了，对不对？谢谢你，谢谢你，应该是这样子，应该是这样子，right？好，请告诉我你的号码。啊，中文啊，随便，下课了。11661303，谢谢。